So the next speaker is Rob Schotsman of Haskoning. Rob is a consultant of Haskoning and did a lot of drinking water and was head of the department, but now he's more on the strategic part, so he will shine a light on the future.
Thank you. Yeah, I'm going to give a presentation about intelligent water. It's a different approach than what you heard in the previous presentations. I make what we call now a holistic approach because we have some things to solve. So I start with my presentation. It started with Haskoning. Well, I'll skip that because we need some time. I hope he's working. Yeah, it is one of our projects. I hope that the other one is coming. New Orleans. We can replace it by Bangkok at the moment. And Beerplaat is one of the biggest drinking water treatment plants in the Netherlands. So we're talking in the Netherlands at least with reliable technology. We have big reservoirs. We have reliable technology. UV disinfection, which makes us able that we can say proudly in the Netherlands that we don't need chlorine for disinfection purposes. We can drink it from the tap directly. But is it so reliable? If we look at a different angle of drinking water supply, these things also happened. A breakage of pipes, we have overflood on the streets, cars going down. And it's all based on a technique which we started 150 years ago by digging trenches and putting pipes in it. And slightly things different nowadays, but in the end it's still digging a trench. We put the pipes in, we cover it up, and we hope it goes well. And then the problem starts, because we don't really know what's happening underground. And if you know that 65% of our investment in the Netherlands is underground, there is a need for more information. We want to know what's happening underground, because if you know that in the Netherlands, if we continue replacing the pipes at the present speed, it takes 200 years before all pipes are replaced. While we say that at least it's 50 years, probably 60, maybe 70, but 200 years is a little bit too much. So we have to do, but do we need to measure more? And what do we need to measure? Which parameter it is, what frequency, what do we need? And if you take that in mind, we have a lot of data already. It's from the lab, quality analysis, but also our assets here. We know what kind of pumps we have, what type of pipes. Also the SCADA system is producing a lot of data. And of course also the GIS information systems is producing a lot of data. And there is much, much, much more to come. But what do we do with all those data if you know that the drinking water sector is still a little bit behind if we're talking about the new techniques that are available? And I produced here some, taking videos, which is becoming a bit popular to see how things work and how you can manage things, but also augmented reality. I will show you later on an example. And if you take that in mind, you can imagine what will happen in the next couple of years. And of course, the cloud is one of the other issues. We have to be prepared that if we run around with our iPad, we want to approach all the information we have available. But how much data? I did some inquiry, and if you look into this graph, you see that if we stated now that we have 100% data at the moment, the prediction is that we will increase that every year with 40%, meaning that in 10 years' time we have to store 20 times as much data as we store now. But, as I already mentioned, drinking water but also wastewater are running a little bit behind. So if new techniques are installed, and the present presentations are saying that we measure more and more and more, the data will explode even more. And how do we come up and see all the data available, and how can we use it? So I do a little test to keep you a little bit awake. Just to fake which one is the odd one out. And just imagine that this is billions of data. I will help you, I hope. It's 8. The 8 ones are the odd ones out, but I think the battery is, yeah, there they are. And now I get the picture. I hope you are awake again. I hope. There he is coming. I'm bored. Because that is also one of the issues we have to conquer, that when having so much data, we are so bored of analyzing it. So we need a different approach to get the right data out of it and to make out of data information, because information says something, data is, I call it, is dead. What says a number 8? I don't know. If I say it's pH, a lot of people will tell, yeah, that has something to say. It's a nice exercise. I hope this is running. I take the example of Vitens. Vitens is a drinking water company in the Netherlands, responsible of 33% of all the customers, 2.4 million customers, of 2.4 million connections, almost 5.5 million customers. They have almost 50,000 kilometers of pipelines. They have 100 pumping stations, and they produce almost 350 million cubics a year. An estimate of mine is that they produce 100 billion unique data records every year. And it's accumulating every year. And if you ask a process technologist, if you want to look into in the history, he wants to have all that data available, because then he can say something that might be happening in the future. So we have a lot of data, which is very valuable. Every process technologist, every hydraulics wants to have all the data available, because then he can predict what's going to happen. But you see in this picture, if we don't take measurements, the pig will drown, and with it, all the information will drown with it, which is that will be a pity. Other challenges we face, at least in the Netherlands, is we have a problem of people getting interested in technique. So if we collect more data and we have to analyze it, where are the people that analyze it? And the aging is also a very big problem. For example, there's a drinking water company that has in one department 230 people, and almost 100 people are more than 57 years old. And that's really a big problem, because that means that within 7 to 8 years, all that knowledge will run away. They will retire, and they will at least benefit from their pension. I will have to wait for that in a few years' time, if there's still something left. But there's also other challenges. So also in this way, we have to approach it in a different way. So structure is needed. And I give you an idea what is needed. I hope he starts. Yeah. You could say, and everybody already said it also, we have the objects and the control and maintenance and the organization, to keep things going. You could say that's the water operation. The water operation is divided for the drinking water company, and you can make any division, you can divide it in anything, but you have the source, you have the intake, you have the water treatment, you have the storage, you have the water transportation, most of the time also combined with distribution, and of course in the end you have the clients, and we want to keep the clients very satisfied. And every piler is creating its own database, and if we are lucky, the data is only stored in one of them, but unfortunately most of the time the data is also stored in several pillars. So what is already going on, and the previous presentations says so, is that we create out of that data already information. So we're building small bridges. But if we look a little bit further and we're going to exchange data between the pillars, which is already also by Kim mentioned, if we look into drinking water, we can say already in advance what is going to happen in the wastewater. We can build, it's really an exercise, we can build bridges between those pillars. And it's therefore necessary that the data is stored very transparent, because then we can use one another's information. And this is creating the data interface, and with that we are able to make our analysis and our strategy at a higher level, combining all the information available, and that creates what we call intelligent water. I made a presentation on Monday for the young water professionals, and I presented in a different way, because if you bring this together to one pillar, saying drinking water, we get the same if you look at into the water chain. Because then, you see you have groundwater, you have surface water, you have the drinking water supply, which is the pillar I show you in a different bridge. You have the sewerage system, the wastewater transport, the wastewater treatment. In the case of WaterNet, and I've shown on top of the slide, you see they also are responsible for flood control. And if you imagine just now, if you can exchange information with each other, you can make better decisions. One example was given by WaterNet itself. They were talking about increasing the dikes, because the water level was probably a little bit higher. And they talked to one of the people of the pumping station, and he said, oh, it's no problem, because we already start 30 centimeters below that. So in the end, they didn't have to increase the dike height. It was not necessary. So exchanging information could lead to so much better solutions and better decisions. So this is creating the Amsterdam Bridge. The bridge between data and information, but also between the data and the information between every pillar. So we got inspiration, because it's very difficult to connect anything with each other, because it's becoming too big. And the apps is absolutely a very genius invention, because you can, what's also in the other presentation was stated, you can make apps for one application and one type of information. But if you just imagine you have one app, another app, there is already somebody thinking, if I combine those two apps together, I can make another one. And so you're also creating something new. So what we need is an app store, but then on basis on water. Because this gives so much advantage. This is a principle, how it's working, you could say, with the apps. I have a reference window. As long as the data is within that reference window, you don't want to be bothered, because the system will take care for you. You only want to see if the dot is within inside, it's no problem. If it goes outside, it's red, and it gives you a signal you have to do something, an SMS or text message or an email or whatever. In this way, you will see that our experts, which are very valuable to us, because we have, it is very difficult to attract people to do this business, you can give them the job that is very interesting. If there is a problem, they know where the problem is and where they have to start. So I give you some inspiration. I used it from Mark van Ekeren. He gave a presentation at the Water Day. This is what we call Imara. It's partly already working at Oase. And it gives you, you could say, a view of all the information available. You're not bothered anymore where the data is, but you can access it in a very kindly and friendly way. So you can see something about here, for example, process flow diagram. There is an app running in the background, and he's monitoring how the backwash is doing. It's something we always forget, but if it goes wrong, it costs an awful lot of money to to create a good filter again. It's also a SCADA viewer, so everybody can make his own viewer. So if you need more of this or more of that, this will be a possibility. Also a message board, which is very interesting. If somebody is coming up with a problem, you could see. Now here you see something different. That's iWatch, what was already presented by Christoph. And eNet is also a kind of app we're working on, which is based on that we measure the pressure and the flow in the distribution net, and we compare it with our distribution model, and we can predict if there is some problems, or if the hydraulic load is different, or the resistance is different. So we're working on that because it can we can come up with a lot of energy reduction, because if you know more about the black box, you can act on that. Yeah. So if you look into the benefits, here you see the cycle again for drinking water, but you can also replace it by the water chain. You get more an integral water operation because you exchange data. You get a quality improvement, which was also stated by Kees if you exchange those data. Energy reduction is also already mentioned by others. Improved maintenance, because you know more, you can make better decisions. And so you get an economic investment program. So, to my opinion, intelligent water is more economic, you get a better quality, and you get also less risk. So you think this is for the developed country, but this is an example that's really working at the moment. It's in Ghana. We introduced flow measuring devices in the distribution net. It was equipped with a battery and a GSM module, which makes it possible to collect data every day, and they send it over once a day. And this gave them so much information about leakage in the distribution network that they could reduce the water they spilled. The funny thing was we only transferred the data once a day, and they were annoyed because they want to have it also every minute. So that's a problem, because in the Netherlands you can imagine if you install those flow measuring devices, you put a solar panel on it and it's working okay. But in these countries the solar panel is very very wanted, so we have to come up with that. So this is quite nice. But the nice thing also here is that because we use also the web, it's possible for our experts in Nijmegen to look through over the web with them. So if there is a problem, they can see what's happening there and they can advise. So you can skip 8 hours flying over there and 8 hours flying back. So this is also, I think, could be a big improvement to transfer our knowledge also to other parts of the world. And now we'll show you some inspiration. Probably you may have seen. I hope it starts. This is on YouTube, and when I saw it I was very impressed. I hope it starts. No. Now I will tell you what it is. Oh, somebody is taking over there. I'll go to the conclusions. I will tell you what it is. It's a story of BMW. You see a big car coming into the garage. The mechanic is stepping up to his desk. He puts on a glass, a pair of spectacles, but it's augmented reality. And while he's standing there, he gets the instructions in his glass what he has to do. So there's a screwdriver, and you see virtual hands screwdriving. But now imagine the water. And the imagination that I have that if, for example, in Ghana there is a problem with a pump, the man puts this on his spectacles. Also, a colleague of mine is doing the same thing in the Netherlands. And they look at the same object because it's transferred to the Netherlands, and we can help them at a distance. It's just, if you take that example, you can imagine, I think if we talk to younger people, they come up with much more advanced opportunities, but also that will create a lot of data. So I come up to my conclusions. I think intelligent water is a must. The benefits are enormous. It's different for our countries because we need a lot of people to do so, and a lot of data is very costly. But for example, in the developing countries, it gives an opportunity to exchange information and knowledge. But what you need is a transparent data warehouse, storing data at one place and making it available to others. You need a balance in the data acquisition. Storing a flow every second is not necessary. So what you need is to find a balance between IT specialists and the water experts. Water experts know exactly what they need. If you ask an IT specialist, say, shall we do it every second? No, it's not necessary. And we have an example for that. We stored online data of the water level in a well. And because we stored it every 5 seconds because they wanted, the network on the head office was running slow, because if we want to present one picture, it takes minutes because they have to come up with all the data. So we have to find a balance in that. What even better is we can start predicting what's going to happen. And especially if we're talking about the investment in the pipe work, if we know if a pipe is still good enough and it will stay underground for 10 years, you can imagine how much money you can spare with that. But we need apps and we need experts to make those apps to make out of data information. And this was the end of my presentation.